Let us solve the particular situation that has been shown. So let us say this mass, the distance of this mass from this particular rigid support happens to be x1. This is the mass m1 and this is the mass m2. So this distance happens to be x2. Okay, so let us look at what pulleys are moving and let us also label the fixed distances between two different rigid supports. So let us say this is the fixed distance d, that happens to be the distance between two rigid supports, and let us say this distance happens to be equal to xp1. This particular distance, this distance happens to be equal to, let us say, xp2, and this particular distance happens to be equal to xp3. This distance is xp3. Okay, so this is my pulley 1, this is my pulley 2, and this is my pulley 3. All the three pulleys are moving, so we need to take the distances of all the three pulleys from the rigid support. So we can write down for this particular string, we can write down for this string, this much part is nothing but d minus xp1, and this much part is nothing but x1 minus xp1. So we can write down d minus xp1 plus x1 minus xp1 equal to length of string 1, L1. Okay, so now for this particular string, it is easy to understand that xp1 plus xp2 is the length of that string. So xp1 plus xp2 is going to be equal to the length of string 2. Now for this particular string, okay, we need to take a d dash, because whenever there are rigid supports involved, we take distances from the two rigid supports to be fixed, and here this is the distance d dash. So for the pulley P2, we can write down this is d dash minus xp2, and this much part happens to be xp3 minus xp2. So what do we get? We get d dash minus xp2 plus xp3 minus xp2. So this is basically going to be equal to L3, and there is a fourth string involved, so this is the fourth string. So for that we can write down d dash minus xp3. This is d dash minus xp3, this much length, and this much length is x2 minus xp3. So we can write down d dash minus xp3 plus x2 minus xp3. This is L4. So on double differentiating these four, we can get down the relationship between the accelerations. So for the first equation, we can write down this. On double differentiating will give us a1 minus 2ap 1 equal to 0. So this is our first constraint motion equation. This is equal to 0. For the second equation, we can write down ap1 plus ap2 equal to 0. This is our second equation. So for this we can write down ap3 minus 2 times ap2 equal to 0. This is our third equation, and here we can write down a2 minus 2 times ap3 equal to 0. Okay, so for the masses, so this angle is theta, this is given. So for the masses, we can write down the force that acts on mass m2 in this particular direction is, so I'm assuming the acceleration of m2 to be A2 in this direction, and for M, okay, so this is M1. Let me label this mass as M1. So this acceleration is A1. So both the masses were initially labeled M2. That's wrong. Both masses are not M2. So the first mass is M1. So the acceleration is assumed to be in the down the slope direction, and that acceleration is A1. And for the mass M2, acceleration is A2 over here. So we can write down M1g sine theta minus T. So T happens to be the tension in this string. So in this string it happens to be 2T, and then this is rigidly connected over here. It passes over the pulley. So here in this we'll get T, and then in this we'll get T by 2. Okay. So M1g sine theta minus T happens to be equal to M1 A1. And for M2 we may write down M2g minus T by 2 is equal to M2 A2. So let us keep a track of the unknowns now. The unknowns are A1, A2, AP1, AP2, AP3 and T. So 6 unknowns, and we have got 6 equations for solving this particular situation using constrained motion technique for solving it. Okay, so this is a very simple situation, although it may appear complicated. So this is the mass M1, this is the mass M1, and this is the mass M2. So as we can see that on the mass M1, 1, 2, 3, 4, 5, 6, 7 tensions are acting in the upward direction, and all have the length as x1. x1 is the length of all of them, and this fellow, the mass M2, has the length x2. So this is the length x2. We can simply write down 7 times x1 plus x2 happens to be the length of the string. On double differentiating we get 7a1 plus a2 equal to 0. So this is the first equation. For the mass M1, M1g is acting in the downward direction, 7t is acting in the upward direction, and the acceleration a1 happens to be over here. Here the acceleration a2 happens to be there. So M1g minus 7t is equal to M1a1. And for the mass M2, we can write down M2g minus t is equal to M2a2. So solving these 3 equations, we can get the answer for the 3 unknowns A1, A2 and T.